Hello, everybody. I'm James Powell, and welcome to our monthly Python Exchange call. The purpose of these calls is to help Python thrive within the National Lab System, within scientific research sites that choose Python as part of their work. Our goal here is to provide additional resources for people who are using Python as part of their research, or to help connect people together so that we don't solve the same problem 15 different ways, that we can share our approaches, share our software, share our efforts and our skills. Remember, these meetings will be recorded, and if you have a question, please do not ask any questions that require any sort of proprietary knowledge. Please do use your best judgment. These are open to the public. Our next event will be in February. At the last Wednesday of the month, we're still working with our speakers just to figure out who we want to have present. But if you are signed up to any of the mailing lists, we will let you know once all of that is decided, hopefully within the next week or so. With that said, I want to move on to introducing our host panelists for today. We do not have a guest panelist for this meeting. Typically, we'd ask somebody to come in and speak a couple of thoughts about what it is that they're working on and how Python fits into their work. But today we've decided to go just with host panelists, keep it a little bit light for all of you. Our host panelists come from institutions like BNL NSLS2 and ANL APS. And let me see who we have joining with us. We have Tom Caswell, Andy Barber, Dan Allen, Julianne Reinhardt, Pete Jemian, and Cam Riddle. And if we could have our panelists introduce each of themselves, telling us a little bit about who they are, what they do, and most specifically, what it is that they would love to answer your questions about, we can jump right into our discussion right after. And so why don't we start with Cam, then we'll go to Pete, then we'll go to Tom and Dan, and then Andy and Juliana. Cameron?
Great. Yeah, thank you so much, James. My name is Cameron. I am the newest instructor here at Don't Use This Code. I actually have lived the academic life for quite some time. I studied specifically psychology and human memory, actually before I met James. And then James helped me realize how good it was, get a taste of outside the academic life. And long before that, I was really into programming. And so I've decided to come out of academia into the corporate world and do some programming and training with James.
And then Pete.
Hi there. I'm Pete Jemian. I work at the Advanced Photon Source. I've been involved in aspects of instrument control for several decades, mostly at the Advanced Photon Source, but also involved in small angle scattering scientific community. So if you have questions about EPICS or Blue Sky implementation at the APS, feel free to ask me.
Fantastic. Tom?
Hi, my name's Tom Caswell. I'm in the Data Science and Systems Integration Group at NSLS2. Additionally, I'm also the project lead of Matplotlib and a core developer of H5Py. I'm a physicist by training, so I'm happy to answer questions about how to use Python working on physics, as well as how to manage large-scale collaborative projects, how Matplotlib, Blue Sky, or H5Py can be applied to your problems.
Dan?
I'm Dan Allen. Like Tom, I work in the Data Science and Systems Integration program at NSLS2, and I work primarily on the Blue Sky project, which is a little ecosystem of scientific Python software for data acquisition, management, access, and analysis, and aims to help specifically the user facilities connect up with this wonderful open source ecosystem of Python and open source science generally. I'd be happy to talk about Blue Sky specifically, or working with large software collaborations that span DOE labs and nowadays international labs, sorting out what parts we can collaborate on and share and what parts we need to specialize on.
Juliana?
Andy? Or Juliana?
Okay, I'll go. So my name is Andy Barber. I work at NSLS2 at Brookhaven National Lab. I am a beamline scientist. We use Blue Sky and our data all the way through to just Jupyter Hub to do the analysis. We take a lot of area detector images, so we're big fans of the NumPy library as well. And in the summers, I've worked with undergraduates to take on sort of test projects who know very little Python and then come away with like actual starting data that we can use for public proposals. So that's great. And I'd be happy to answer questions about any of that.
And then finally, Juliana.
Yeah, my name is Juliana Reinhardt. I'm also a physicist by training and used to be a beamline scientist at International Synchronous. And now I'm a research scientist in the ALS computing group. So we are building, together with people from the other synchrotrons, we're trying to build analysis and data acquisition tools using Blue Sky and other Python tools. So I'd be happy to answer more high-level questions when it comes to maybe exchanging experiences on like building prototypes using Blue Sky and others like that.
So starting off, I have a question for the scientific staff, which is, if you were a scientist and you had very little free time among all the different responsibilities that you have, how valuable is it for you to carve out that free time to learn Python if you don't already know Python?
So I'll jump in here. I think it's either you take the time to learn it or you learn it as you go, and it makes life so much easier, especially if you're going to use Python in a way that it's very conversational. It's easy to read the code, and so that's why it's great also to work with undergraduates who may not have had been exposed to that, or even postdocs just getting started. It makes it really easy just to ship them a notebook, and so they can see how it works, and then they can take over analyzing the data, and you can go do other things. So that's what I like about it.
Juliana, did you have something to add?
Yeah, I would also say, of course, you could always take the time to learn it specifically, but probably just start learning it as you go. The community is big, and you will make quick progress in the beginning. Of course, then when it comes to more advanced applications, you might want to like extend your network, like for example, coming here. But yeah, I totally agree with Andy. It's making things so much easier, and yeah.
I have a curious follow-up question for Pete. When you tell your scientists you need to learn Python in order to be with it with the next generation of tools, one, do you present this as being a large undertaking, or do you try and say, well, it's so easy, you can just kind of pick it up in an afternoon? And two, if you present it as a large undertaking, how do you motivate them? How do you get them to want to do something that's just yet another thing on top of all of the responsibilities they have?
It's that motivation is the real biggest obstacle. People need to be convinced what's the value added to divert their time to this activity. Mostly for people who are absolutely newcomers to Python, I try to advise them about the simplest tools so that the apparent complexity is not so high to make a start. But it's always a competition to get their time for a new activity. So you try to appeal to their sense of what communities would they be buying into. Look at the
So what communities are they buying into, at least for your APS staff?
So for the APS staff, they have the data science community already. We have ample expertise on site within the lab for understanding Python. There's lots of different libraries, lots of expertise for using Python. So these are advantages over so many other languages that people might implement in.
And I'm curious, Dan, are there any complaints that you've heard a million times over about why not Python, or not yet, or not quite, that you just like to put to rest and answer once and for all?
Boy, what a simple question. I guess the argument that I'm engaged with the most on this is that while Python does a little bit more than you need in the simplest cases, if we invent our own private language to solve a specific problem, it's a lot harder to Google your questions about that private language. And by buying into something that a lot of people already use, not only do you get the training resources and likely good Google results, but it's much easier to hire people and to collaborate with people who already know what you're talking about. So it might be a higher buy-in than the most purpose-built tool you could imagine for a given task, but it's a more generalizable skill, and lots of good things come with that.
And I have an open question related to something that you said, because this, can you Google for it or not, doesn't that have a specific implication if you're a user facility, if you have outside users who are not full-time staff from universities or whatnot, who have to interact with tools, but you don't have, 24 hours, or you don't have 2,080 hours of their time every year to bring them up to speed?
Yeah, I think that really does cut both ways, because on the one hand, when they're home at their universities in sort of a data analysis mode, speaking as a user facility anyway, they can help themselves. At the same time, if they come in knowing no Python and they have 3 days of access to X-ray beam or something like that, they have a very short budget for upskilling into knowing what to do. And so there has to be a recipe-driven, practical, how-to guide style document of like a page worth of information that gets them from whatever they come in with to what they need to know to feel productive.
And I'm curious for our scientific staff, in practice, how did you tackle this challenge of you need to know the physics, you need to know the instrumentation, and then you need to know enough about programming? How did you come to terms with this? How did you develop mastery on your end?
So I'll jump in. So I guess it's sort of, like building blocks. You build them slowly. So in the instrumentation and the scientific stuff I learned in graduate school and as a postdoc, I knew a little bit of programming, and I understood how it worked, and I've taken some classes, but what I was doing before didn't need data analysis at a very large scale. But it's just impossible with all the data you swim in, especially if you're a beamline scientist and you're responsible for making a beamline perform for a user experiment. And so the way that I learned Python was just sort of trial by fire and a lot of Google to get started. And sometimes because the blue sky can be very complex, and a very fast way to solve sort of problems on the fly would be just to Google the traceback instead of the error message. And a lot of times that points directly to what's actually wrong, or at least a way around it. And so that's a useful thing for me.
I'm curious, as a follow-up for you, Andy, you're a Blue Sky user, and in a moment we might talk briefly about this Blue Sky project that constitutes quite a bit part of all of our lives. How much Python do you really need to know to use Blue Sky effectively?
I think that's dependent on the beamline and how excited they are about Python. I think I can speak for CSX. We rely heavily on Blue Sky plan stubs. And so basically there's a web page where it will show you all the different scan plans that you can put together. And so you don't need to know that much, maybe just 2 or 3 things. I think that can be taught on the first day. I think the harder part is understanding all the details of the instrument and what things are called, and that's a challenge at any beamline you go to.
And I'm curious to hear a follow-up from Dan or Tom. How much Python is a Blue Sky user expected to know, or what's the minimum amount of Python that a Blue Sky user is expected to know, and they can't just copy and paste their way to some working code?
It depends on how custom what they're trying to do is. Bruce Rabo, who's on this, I think on this call, told me once that one of his users said, "I love Blue Sky. It's just like Spec." And Spec, if you don't know, is the name of the domain-specific language that Blue Sky is sort of aiming to, be the next generation of, I guess. And so it seems like you can build something out of Blue Sky if you put in a lot of detail-oriented effort, as Bruce did, to make something that users can use without much of a conceptual understanding of Python. On the other hand, if you're opening up the hood and you're trying to make some really sophisticated thing that's maybe a little different than what the beamline usually runs, and is something a little bit more than just sequencing existing, out-of-the-box objects, then you'll need to know some Python, and that learning curve goes as high as your ambition is complex, I would say.
I have an interesting follow-up for Tom, because we hear about these, internal or proprietary or, very niche languages like Spec or Yorick. As a designer of these kind of tools yourself, how do you make sure that something like Blue Sky or OFID doesn't become yet another Yorick or Spec or something like that, just happens to have been written or happens to be surrounded by this use of Python?
A risk of that, the more specialized you become, the easier it is to develop a basically domain-specific language within Python. However, I think the way to protect yourself against that is to always think about how, as you're building frameworks, provide an escape hatch for your users down to the underlying language. And if you're careful to preserve that escape hatch, you'll naturally keep yourself from diverging too far away from what someone who understands the underlying language would expect.
Does anybody else want to add anything on to cases where you get a little bit too deep into the tool and you discover, hold on a second, this isn't really Python anymore, this is some particular variation of Python? Juliana, do you have something that you wanted to add?
Yeah, but not this part. I wanted to ask before how to get people on the hook. And as controversial as it might be, for some of the beamline scientists I see here, it's often that they get a little GUI to play with. So I personally appreciate the development of blue sky widgets, where you can have the same functionality as well from like a little GUI, because that's how you get them. Then they like it, and then they want to look into Python.
I'm really curious about something at least related to Blue Sky, since we have a lot of Blue Sky users represented here. It's considered that the development costs for a graphical user interface tend to be very, very high. Some beamlines, like those that Pete helps to manage, they have full Qt apps that they're building from scratch, but generally the cost for building something and maintaining something like that is considered very high. Is it the case that the use of Python and specific tools like Blue Sky can devolve your user interface down to something that fits into a script that you run from the command line or a notebook? And is that a way that you can actually recover time or cost that would be spent building very complex point-and-click interfaces? Pete, do you have any thoughts on that?
Getting a GUI is a strong demand at the APS. Blue Sky comes with a command line interface. In the experience, I've got two strong communities, one that always wants the expert user access from the command line, and others that want the error protection that comes out of using a GUI. These are two very competing interfaces, and for the effort that we have, we're still just providing the command line interface. I love the idea of providing widgets, but they're not the answer to all the problems.
Opening up to anybody else, does anybody else want to talk about how perhaps these frameworks, these tools can at least reduce the overall cost? My only experience in building UIs is that they're very time consuming and very complex to build correctly.
I could draw on a conversation I've been having with Marcus Hanwell, who joined our program from industry, from Kitware, and he maintained a really high-end, high-performance C++ tomography analysis application. And it's with a lot of thought into the user interface and, of course, the performance given the scale of the data. And it seems to be a real challenge to build something of that quality for everyone in a user facility, right? And to have a collaborative development workflow going with scientists is much easier in a command line mode. The complexity of getting everything right in a GUI, even just keeping it from crashing or running away with the memory is something that takes a lot more software sophistication than simpler tools can get. So I think the best that we've come up with so far is to make dime a dozen notebooks and really simple reusable widgets that do 80% of what people want, and then hope to find the funding and the resources to build applications of the quality of TomViz, but they would have to target a large swath of users. I don't think we'll ever have enough resource to do that per beamline unless you've got a special beamline that has the self-motivation and the resource to really do that for themselves. Speaking with my software support hat on, I suppose.
Any other thoughts on that topic, Tom?
Actually, I could jump in. I think the thing is that one of the trade-offs of a GUI is that while it does make it much easier to do a specific task, it makes it much harder to do any tasks that is slightly away from what it was designed to do. And so for some science applications where the beamline really is in a production mode where there's a known measurement, and the interesting science is in bringing in the new samples to run that technique on. That is, like tomography, that's someplace where a dedicated GUI is very valuable. But some of our other beamlines, which are much more experimental, and by pushing the technique, that's how you can push the science forward. Those beamlines will never be amenable to a GUI because it will never be flexible enough to get the science done.
Fantastic. If we want to change tracks a little bit, I'm curious about one thing. We've established that it's valuable to learn Python. It's valuable to invest in these frameworks to create this or to buy into a community here. What I'm curious about is how much is it worth for a scientist to buy into not just the language, the tooling, the infrastructure, but the community engagement behind that? For example, I know that Tom and Dan are regular attendees at Python conferences, both those related to data science, but also related to scientific computing, and also those that are generalist. But Andy and Juliana, I suspect that in your busy schedule, you have time for maybe a scientific conference around your area of work. But is it worthwhile for you to attend a general Python conference? Is it worthwhile for you to attend a PyData data analysis conference? Is it worthwhile for you to engage in those communities from that perspective?
So I would say that I'm definitely interested in doing that. I'm looking forward to it, but there are also a lot of people that in our DSSI group that go to those conferences, and I think it's challenging to get a place in the line to go to those. So.
But if you had an opportunity, you feel it would be enriching.
But yeah, I didn't look at it before, but I looked at the sort of all the things that happen, the events and the different sort of tutorials even. Like I was like, I should have gone to that like 5 years ago. I shouldn't have waited until now.
And Juliana, do you want to add something?
Yeah, I mean, since I'm now in the computing group and not a beamline scientist anymore, so I could certainly justify to go, and I would love to do so. But I guess for the majority of beamline scientists, at least at the ALS, it would probably not pay out at the moment, mainly because we're not so Python-driven yet, which I personally I would encourage people to, but I think at the moment it would be, they couldn't afford it in terms of where should they find the time, so yeah. Encouraging, but tricky to get there.
How do you find that balance between not isolating yourself from anything that might be cross-disciplinary, but also not wasting your time chasing down a bunch of things which might not actually really apply to your work?
Yeah, I think that's the issue. That's the really big issue.
Do you have any strategies or thoughts that you might be able to share for how you could do that effectively?
You clone yourself? No, it's not like, no, I don't have a good solution for that.
Tom and Dan, have you ever given any advice to scientists who are like, I'm kind of interested in PyData, kind of interested in PyCon, kind of interested in SciPy, but I'm not sure if it's worth it for me to show up?
I mean, the advice of clone yourself is good advice. I'd like to arrange for that as well. I think the advice, an argument I would give in favor of going to SciPy is meeting other users of the tools and meeting the people who build the tools will help give you ideas about how to use them in ways you didn't necessarily imagine were possible. So early on in my career, I spent a lot of time answering questions on Stack Overflow, which was a very effective way to learn what was just possible with Python, because people would have problems I had never thought of even trying. But then helping them solve their problems, you learn what is possible. So when you encounter things like that in your own work, you have the memory of, I helped someone else with something similar. I can do this.
I'm curious, Tom, as a core developer.
SciPy talks are recorded. So, sorry, I'd add that the SciPy talks are recorded. So even if you can't go, those tutorials end up as 3-hour YouTube videos, which is less engaging and it makes it harder to carve out the time, I think, than just leaving the state. That always helps. But it's still a good resource.
Dan, isn't it the case that many will argue that the value in these events isn't even the talks themselves, but the connections that you make outside of the talks?
Sure, I learned the term hallway track. I don't really know how universal. Hallway track is great, and it's where you learn where the new stuff is happening, and yeah,
Now,
that's probably worth it.
I had an item I was a little bit curious about for Tom, who, as we all know, manages a very, very large, very major project in the Python ecosystem, namely Matplotlib. Tom, you allocate every month or every week some amount of time that you want to spend working on Matplotlib. And out of that time, you allocate your time to managing the project, to going through GitHub issues and whatnot. But presumably in your mind, you allocate some portion of that time to working directly with people who have questions and answering those questions. Some scientist says, hey, how do I do this in Matplotlib? How do I help them out? One, how much of that percentage of time do you like to spend? And two, is this something universal? Is it the case where through calls like this Python connection call and through bringing in guest panelists, that a scientist who's using a tool can go to an open source developer in the PyData ecosystem and say, hey, can you spare a little bit of time to help me with some novel use case for your tool? Tom, what do you think?
So I say week to week, the time I spend on those various tasks tends to vary wildly week to week based on what the needs are that month or that week or month, or what interesting questions have been asked in the various support channels. I will say I do very much enjoy getting questions in either the Matplotlib getter or discourse that I don't immediately know the answer to. Probably every other month we get a bug report where my first thought is, wait, we do what? Where then, and then once I get over that, then you start figuring out what the actual bug is. By and large, the users of these projects are very smart, very clever people that come up with really interesting ways to use the tool to get done what they want to get done. And enabling that is one of the things that keeps me going at this. And I think, obviously it depends on the person. Everyone has their own personality, but I think a majority of people who have been attracted to be maintainers, particularly volunteer maintainers, at some point in the open source, in the scientific Python stack, are doing it because they enjoy helping people solve their problems. And if you go to the open forums, either the mailing list, the discourses, Matplotlib uses Gitter, NumPy uses Slack, and ask questions, it's very likely you'll get help sorting out whatever your problem is.
So I want to put a question to Pete, Andy, and Juliana. If it were the case that you buy this, that the value in attending these events is often not really seeing the talks, which you can see on YouTube afterwards, but in meeting the core developers of these projects so that you can then later say, hey, I have a really, really weird bug or a really weird use case. Can you help me with this? And they are actively interested in helping you. Would it be valuable for us through this group to make people aware of what events are coming up, who might be at those events and who might be worth talking to, and to facilitate some of those introductions to say, hey, this is a core developer of Pandas, this is a core developer of H5Py, this is a core developer. What do you think, Andy? Would that help you whittle down the amount of time that you spend and the amount of worry that you're like, oh, this might not be worth it?
I think so. There are a couple things that I always wish the library would do, and because the library doesn't do it, I have to go find another library that will do just one thing. And so it would be really nice to get those conversations happening. Yeah.
And also, if I could add to that, I think frequently one of the problems with big libraries that are very cross-domain is that frequently multiple domains will have different names for the same underlying thing. And so if in your field you learned one name for it and the library was written by someone who used a different name for it, it's very easy to see a feature that is what you need, but not recognize it as what is you need because it's spelled wrong or the inputs aren't quite what you're expecting. And by coming to the projects and describing what you need, hopefully someone can help make that connection. And then we can, you get your problem solved and we can improve our docs to help the next person find the right thing on the first try.
Pete, Juliana, did you want to add something onto that as well?
I could add something. So I think in order to answer this question, I would see at least two different kinds of beamline scientists here at ALS, for example. Some that are already relatively into Python, at least a little bit here and there. For them, it would be excellent to point that out. It would save them so much time, and maybe there could be even an option to collect their requests in the beginning to then point them directly or something like that. For them, it would be excellent, and I could already imagine a few people who would benefit tremendously from that. For others who are really they have the tool that they got from the proprietary whatever instrument manufacturer. For them, it would be very hard to get them, and it would still be quite a barrier to get them in there. But on the other hand, who knows, right? If they maybe then exchange with another colleague and they see, I could actually maybe submit a certain request where I'm stuck with the proprietary software, maybe that would help to get them into it too.
And Pete, did you have something you wanted to add as well?
Yeah, I think I'd like to add in, because part of the difficulty in joining, it ties into the previous question, why do I invest in a new technology, is I'd like to know what's the size of the community that can support. Am I reliant on just the person who introduced me, or is there a larger community? So having events such as this and having them well known has high value in showing to my community that there's many people who can answer your questions, not just me. Many people who can guide you in a new direction, maybe better than I can do that. And by attending these events, you'll also polish up your tools and meet the people who can answer those questions more quickly.
Changing tracks very slightly. I have a question for Cameron. Cameron, as we understand, your background is not in the hard sciences, but in psychology. And it's the case that many of our users in the Department of Energy, in these national labs, are not users who come from backgrounds where they have some implicit level of technical background. It's not the case that they would just necessarily in grad school have run into MATLAB, a bunch of times. And so Python, NumPy is not that different. When you're approaching users who have significantly less technical background, who may have never done anything computationally, but they're still hard scientists, maybe doing something in biology and chemistry, and many of these may be even people at the labs represented here. How do you convince them that the very long path to no background in programming to being able to do something useful is worth embarking on?
Yeah, that's a great question. One thing that I would always say to new students coming into graduate school is that you should learn programming in order to, 1, perform experiments faster, 2, increase the reproducibility of your experiments. This is applicable to the hard sciences and to the soft sciences because it just really changes the way that you think about data and the way that you are able to work with data of much more complex types. And so I would always advocate for anyone who's coming into the field, especially as a student who might be a little overwhelmed even trying to get into the field that they're in, to just also throw in programming in there as something you should pick up along the way. You don't need to be a professional at it right now, but in the long run, the benefits greatly outweigh the costs.
Andy, do you buy it? If you were to start all over from scratch and design your undergraduate and graduate curriculum, knowing everything that you know, would you have pushed some of the programming knowledge earlier than it ended up for you?
Yeah, most definitely. I think I wish I would have known Python and it would have been much more accessible instead of having to have a Unix system to get it going. So, yeah.
How early in your career do you think you would have introduced that in the ideal case?
Oh, as soon as I started graduate school. I mean, maybe for undergrad it's too much, but I think it's interesting. They spend a lot of money now in undergraduate labs to do sort of automated experiments that will, do a pH titration with a drop counter and a pH meter, but then they go and they use Excel to analyze it, which is, kind of breaks my heart a little bit, but, slow steps.
Does anybody out there have any other experiences or thoughts on when is that earliest point? So far, Andy said, grad school is probably a very appropriate place to start, but try and push it earlier than, your professional experience. Any other thoughts from our panelists?
I have another 2 cents to add. If nobody else has any comments to add, I would even advocate as early as some point during undergraduate. Having recently been in graduate school myself, I know for a fact that a lot of incoming students are already overwhelmed in the position they're in. They need to learn the topics that they're studying. They need to learn statistics, more advanced statistics in almost every field that will be relevant. And now you're saying they need to learn programming. There's, just kind of the three nails, and they're just like, oh my gosh, like I don't know anything, completely overwhelmed. And it actually does cause a lot of first years to get burnt out rather rapidly.
Did you want to add?
I would agree. I would also advocate for pushing at least basic programming down to an undergraduate science curriculum. Just like we expect undergraduates to do in physics to do linear algebra and calculus, I think basic programming, probably in a high level language, should be considered a standard part of at least the physics curriculum.
Tom, do you buy it when people say, I'm worried if I start doing programming that I'm going to no longer be a physicist and I'm just going to be a programmer, as might have happened to you in your own life?
No, because I think there's enough computerization and automation in science these days. I don't think you can be a successful experimental physicist without knowing how to program.
To steal one of Tom's metaphors from out from under him and apply it to this situation, it would be like saying, I'm worried if I start writing grant applications, I'm a novelist. It could happen, but maybe it won't.
And Pete, did you want to add something?
I did have a point. The point I want to make, I've got a daughter who's in college as an undergraduate in a microbiology program. She had to take a class in bioinformatics in the last term, which involved a part of the term doing Python programming, but not just the trivial sort of desktop related make a for loop, but actually involved mining databases online for information regarding DNA sequencing. So it involves some searching and sifting and sorting. She learned quickly that Python really isn't what she wants to do in life, but this is a basic skill that's necessary for the application of science. I won't say it's just restricted to bioinformatics. I think that's a nice place where you see a lot of databases with the protein database kicking in. But that's an example of why it's necessary to develop that vocabulary at an early level, and even earlier than undergraduate is tremendous, but at least the baseline skills need to come in at that level. Don't wait until grad school. In grad school, we had a professor who required every student from his grad student lab to complete a new software package for that group. That was one of the requirements they had before they could get their PhD.
So Pete, there's an interesting thing that came up in your comments here. What if somebody starts doing a little bit of Python scripting, maybe in grad school, maybe in undergrad, and they look at that and just programming as a whole, and they say, this isn't for me, I don't like this. Maybe I can be good at it, maybe it's something that I can do, but I don't enjoy it and I don't want to do it. And one of the nice things about the national labs is they often find a place for people who have some desire to do the science, and they can find a place. If you don't want to do grant writing, they can find a place for you. Is there a place for people who want to do the science, but really, really genuinely they don't like the program? And what is that place?
We see that time and again at instruments. There's specialization all across the board. So even if programming is not your forte, I still say that you ought to be able to understand some language at some point so you can understand how you could implement, but you don't have to be the one who does that. So maybe your forte is making samples. Maybe you do vacuum work. Maybe you do the grant writing. Maybe you know how to do the analysis. all of these are useful. And they have places, the labs, as well as in companies.
Now, here's my open question for our other panelists. How big of a space is there these days? Is that a space for, people who don't want to do programming? Is that as big as it was before, or is that narrowing as things become more programmatic, more systematic? Juliana, I see you have some thoughts.
Yeah, I think if you had asked me before I started my PhD, I would have told you, yeah, you can do some physics without knowing how to program, right? Before I even started graduate school. At these days, I would say you might be able to do it, but you don't want to be in that place probably, at least for physics, because you make yourself dependent, and you probably don't want to be that, right? Because you have ideas and you don't want to ask, in your early stages, at least you don't want to ask someone to program it for you. So if, as Tom said, we make it kind of mandatory in the very early stages, then later on you don't find yourself in that position. You don't have to love it, right? You don't have to become a programmer, but I would definitely say it's narrowing.
Andy, do you agree? You don't have to love programming, but it's not going away. You better just come to terms with it.
I think so. I would say most generally, yeah, it makes your life easier. I think also too, it's really good to have at least a basic vocabulary, so when you ask a developer for something and they say no, you can understand why they say no. That's often useful.
I would say that maybe it's the case that programming can be more enjoyable than you expect, in that it can sometimes give you an opportunity to really specifically model interesting aspects of the underlying problem you're trying to solve. And so it may not be that dissimilar from the underlying science that you're doing. And so if you hate programming, maybe you just need to think about how to write codes that do things which are a little bit closer to your work, and how to use Python to express, what you're trying to do in such a way that that distance between it being a little bit too techy, a little bit too far away from the science is minimized. Now, I don't know if you all buy that or not, but why don't we take just a couple more questions for our discussion, and then we'll wrap up. I want to give our panelists an opportunity to ask each other any questions that they might have about their work or about these things. And I'll start this off. We have many panelists today who are Blue Sky users, and they work in different areas of the Blue Sky project, from helping to develop the Blue Sky project and some of its subprojects to using it. I would love one of our panelists to ask another panelist about what's the long-term future of Blue Sky and how large of a scope is it for scientists at the national labs. But I'll leave it to our panelists to ask each other a few questions.
Pete, how long do we have to keep this up before it was all worth it?
I've got a question for Andy. Andy's an instrument scientist at one of the national labs. And how difficult was it for you to learn to use the Blue Sky system? Let me stop my question right there first.
Well, I think I was in a unique position because we started as Blue Sky wasn't even Blue Sky, and the software was changing regularly. So I think it's hard to answer that question, but what I can say is teaching other beamline scientists, I think it's also really valuable, especially if everybody's getting started, to have one person on the team that knows how to use Blue Sky proficiently, because it just makes the learning curve so much easier. You're not going to learn it in half an hour in a way that maybe a instrument scientist would need to be proficient in Blue Sky. But I think in teaching users, you can simplify it to a few sort of copy-paste kind of things, as long as their experiment doesn't get really complicated. But does that answer your question, Pete?
I guess the follow-up question, you were starting to answer that, is what do you advise a new instrument scientist who is starting out? What would be the effective strategy for teaching them this system?
I personally think an ambassador program based on peer scientists that use Blue Sky is a really powerful way to go, but that's expensive and it takes time. I personally think that's the best way to do it, though.
Thank you.
I have a general question, as obviously I don't work there and I don't use Blue Sky, but we had something pretty similar within the neuroimaging community when I was working at the National Institutes of Health. We had a core team that would put together, right, this neuroimaging analysis toolkit, right? It had a command line interface and a nice GUI. What programs, or are there programs that you offer where you do like workshops that's open to multiple other labs and things like that?
It may help, Cameron. You might want to direct that question. Everybody is rushing to answer it.
Take Dan or Pete. Does Blue Sky do like open workshops where individuals can come in and maybe do like a week-long intensive thing where they get to learn the software?
We've done annual users meetings at the NSLS2, and I think APS is doing trainings very regularly right now as they're scaling up their usage. So that has been the main event. I guess COVID has cooled off some of the cross-pollination that we used to do through travel. But it was also often the case that when a new instrument tries to move over, that someone from the software support side like me or someone I work with would go and kind of help them have a good experience out of the gate as much as is possible. And now a lot of that collaboration has moved to the Nikea Slack, which is more partly Blue Sky centric, but partly just people at user facilities or general large scientific instruments with software problems talking to each other. I guess that's my answer. Pete, did you want to add to that?
No, I think you were hitting that. We have a variety of less expensive to manage material on the web, various tutorials, a Docker or some sort of virtual machine that you can run, so a virtual environment to try the software out. I think that's done to leverage the labor it takes to run a week-long meeting, because running a class takes a lot of investment.
And I should note that Pete and I have also run, I believe, 2 or 3 Blue Sky courses at APS last year, specifically as 2-day courses to ramp people up on Blue Sky, OFID, Data Broker, at the tail end of some introductory Python courses and some NumPy, SciPy courses that we've done as well.
It takes a bit of effort just to make sure that the class is going to be successful within the limited time. So that effort is very much appreciated.
I would love to have one of the panelists ask another panelist about where Python is going this year, or where Python is going in the 5-year or 10-year frame. We're at the very beginning of the year right now, and it's always a good opportunity to take inventory of all of the things that you're building your career upon. So I'd love, especially one of our scientific users, to express how your careers and are built upon the hundreds or even hundreds of thousands of lines of code that you write. And what does that mean for you in 2022? What does that mean for you from 2022 to, say, 2032? But I'll leave it to our panelists to formulate their own fears, concerns, and thoughts into a question.
So I guess I'll ask a question. I guess the thing that kind of I struggle with, that kind of I worry about, is like I have all this process data. It's really nice. How do I save it in a file? Which file type should I choose? Does it matter if I want to ingest the data later? Should I pick a different file type? What about parallel compute? Because there are a few different libraries that you can use to compute things in parallel to make the code more performant. But then, then the file types that you write actually change. You're going to do parallel compute and ingest that data in a parallel way. And it seems to have like a lot of tuning and vice that's necessary. And it doesn't seem like all that stuff is in one good place for like a novice person. It seems a lot of that documentation is written for developers. So I would like to know where Python is going in terms of making that easier. Is that something that is on the horizon?
So
I'll try. Oh, go ahead, Tom. You first.
I was going to take it and then throw it to you, Dan. So they say
Oh, boy.
So I think identifying that serialization formats and how to ensure they're performant against both read and for write operations, and to make sure the files are performant for your read operations is a very hard problem in computer science. In fact, this week, the DOE Oscar is having a workshop about the future of intensive I/O based applications. One of the things we've been working on is Tiled, which is which I was going to pass to Dan. It's a project to try to allow the scientists to become decoupled from the exact data formats as much as possible.
Yeah, I think this connects up to the core of James's prompt of what about the future of Python. And I think the longer that we work in this space, the more I think our solutions go from look at all this cool stuff we can do with Python and these libraries that already exist to more transcendent concepts and hopefully more general and transcendent tools. So we started with, well, we'd really like to get everyone's data into pandas because it's just like NumPy, but your columns can have labels, and that seems really useful, and it's good at time series alignment, and we hear that that's a thing people do a lot. So we'll just focus on getting data into pandas, and maybe we can build an entire empire based on that. And the longer you sit there, the more you realize that not everything in the world fits well into pandas, and not everything in the world even fits into any Python library at all. And so starting with the Python ecosystem as a starting point, and then going a little bit broader and thinking about letting people thinking about making the standard accessing the data organized in a certain way with a set of maybe names and general layouts that we agree on, but being flexible about pandas versus Xarray versus other tools and HDF5 versus some modern cloud-based alternatives. And I think then Andy's point is that's still a really dizzying space, and I'm not sure which one I'm supposed to use for my problem. And so I guess we're starting with, let's make sure that we have a way to smoothly transition from today's favorite tool to tomorrow's favorite tool without breaking everything. And then let's produce good documentation and examples to help the scientists that we work with navigate that change as it takes place over years and decades.
Dan, may I put you on the spot and ask you 3 very related questions? One, if I generate some experimental data today, is there an answer for how I can store that data so that I'm guaranteed to be able to access it in 10 years' time? 2, if I generate some analytical code in Python to work with that data, is there an approach that I can take where I'm guaranteed to be able to use that analysis code in 10 years' time? And 3, if I happen to do that analysis using some of the tools in the Blue Sky ecosystem, is there a guarantee that Blue Sky will still be around and I'll still be able to use that Blue Sky framework related code in 10 years' time?
It depends what you mean by use, I think. Are we talking about run the exact same analysis start to finish, or do something similar and a little bit different and adapt it to new needs, right? I think Blue Sky and Python is maybe as good a bet as anything, and as a very popular language, and Blue Sky an increasingly popular framework. It may be as good a bet as you can get. Who knows what happens in 10 years? The best answer to is there a place to put it? You have to find someone to pay to keep it, which is the challenge. I think the DOE user facilities usually see a year, though they tend to go longer. If it's a small-ish result of a paper, there are free services like Zenodo or Figshare that will keep stuff like that. For the analysis, there are platforms like Binder that are based on a federated community with multiple funding sources that will let you and increasingly anyone run the code. So I think you can always get to a technical yes, but the question is, can you make it easy enough that someone will bother rather than just doing it over again themselves? And hopefully tools like Blue Sky and Python and certainly Binder lower the barrier to making the old thing work as compared to just starting over in 10 years because everything's different.
And I'm curious, for our Beamline scientists, do you buy it? Do you know if someone were to say, you're doing some experimental work today, in 10 years' time, somebody's going to really care about reproducing this, write it up in a way where it can be reproduced in 10 years' time. Do you feel confident that you would actually be able to do that? And is it worthwhile? Is that a scenario that is relevant to you?
So I guess I think most of the journals now are really, getting more strict on their data policy and the kind of file formats they expect you to upload. And I think that kind of ensures that it's general. Whether or not the library will be available is problematic. I know something not started by me, and maybe it was Dan Olds or Stuart Campbell or Phil, but putting your code that you used in a GitHub repo and all the dependencies there is a really good way to make sure that you can at least maybe have hope of using the same exact version of the library. But I think in 10 years' time, do I want to access the raw data collected at the Beamline yesterday? I hope not. I hope I have other problems and we're doing new things. So.
And Juliana, did you have some input for that?
Well, I'm not a scientist currently anymore. I would have a question beyond that with respect to how to integrate proprietary software with open source Python developments. Because I hear from the Beamline scientists, yeah, my users, they won't go away from this particular software because it does all they want to do at the moment. And I don't know if there are thoughts beyond. Then I usually try it with a parallel way. But are there any suggestions from the other panelists on how they would cope with that?
Let's take that as our final question for the evening. Any thoughts on how we can integrate, as quickly as you can and as briefly as you can, proprietary software with some of this open source software we're working with?
I guess I'll take a crack at this. So I think one approach is just to meet them where they are and say, okay, your software expects this file format as input. We can write that file format, and at some level pushing them to move to a new set of tools that we probably will have to build for them over something that is working for them to get their science done, it may not be the best value proposition. And then where you would then pick back up is that program has some outputs that it can't handle yet. Now you can bring that back into Python and start doing the next layer of analysis back in Python. And once both ends of those start to be more in the open, at some point it will be worth the time to rewrite that, what you're essentially using as a black box processing step, into something more open that we can work with directly, either for performance or for reproducibility reasons. And I think just offer them a carrot and try to work with the people who want to work with you instead of trying to convince everyone to do it your way.
Any final thoughts on this question? If not, why don't we take final thoughts from our panelists for the evening? We'll go in reverse order. Share with us any final thoughts you have from our discussion, maybe some provocative thoughts or any points that you really want to drive home. But final thoughts, Andy?
Oh, it's been I guess a whirlwind of an event, being the first time I've participated. I don't really have any final thoughts, but I think that this was generally informative for me, and I look forward to future conversations.
Fantastic. Thank you, Andy. Juliana?
Yeah, I also appreciate all the input from today. For example, also from Cameron, from a bit different side, because this question of how to get more people on board in the Python community is not so easy with some individuals, I guess.
Tom, any final thoughts?
I continue to be excited about the Python community and the broader scientific Python ecosystem. The amount of good work that's being done, across the core projects, across Blue Sky, in the high energy physics community, across the light sources, the work that's being done in the biospace. There's just so much going on, that anything you want to do, there's a good chance someone is already doing at least some part of it, and everyone does seem to be friendly, open, and willing to collaborate.
Dan, your final thoughts?
Yeah, I really appreciate the wider variety of perspectives on this call. I think it's a far and away better discussion, and I look forward to more of these and maybe bringing in a still broader perspectives on future panels.
Pete, your final thoughts?
I too appreciate being part of a larger community, identifying part of a larger community. It helps me to tune my thoughts, my directions at the APS. But it's also encouraging to see that finally we've got a tool that can replace the scientific use of Fortran that's sufficiently broad, has deep enough libraries that it's not that Fortran is bad, but you can do so many new things in Python and it becomes so much easier there.
And lastly, Cameron, any final thoughts you'd like to share?
Just that I had a fantastic time speaking with the other panelists. It's been really enlightening hearing how programming plays a role in your work and seeing that parallel in my own academic past.
With that, thank you all for joining us. We'll adjourn at this point. We'll resume with our February Python Connection call on the 23rd of February in the same time slot. We'll let you know as soon as we have our speakers and topics set for that event, hopefully in the next couple of days, maybe next week. But with that said, thank you all for joining, and special thanks to all of our host panelists for presenting and for answering questions for us tonight. Thanks, everybody, and we'll see you next month.